Hello everyone, you are most welcome to my channel. Today we shall be learning how to implement MadSort algorithm in Python. My name is Reni Atairo, aka AfroBoyTex, and I'm glad that you chose this particular video for MadSort. So what is MadSort? MadSort is basically a divide and conquer algorithm, and I know you're here just for a solution, but it's just a small introduction. And I think it was discovered or invented or developed by John Von Neumann in 1945. And what it does, it is an outplace sorting algorithm, and it requires actually more space. It divides the list into two halves, and then also those halves are divided again until the whole problem is solved. So it divides the problem, solves it recursively, and then merges the parts, hence the name merging sort algorithm. So let's get started. So we're going to create a function. I'm going to call it actually merge sort, which is going to take in an array. So we're going to start with our first implementation. If the array is less than 0, that means basically the list is sorted. So if the array is greater than 0, it means we have to work out our way of sorting it out. So that's where we come in. So we shall have this, like I told you, we're going to declare variables that are going to help us in doing this. So we divide the array. So it's going to have the midpoint that will help us divide this array. So the length of this array is going to be flat divided into 2 to get the right part and the left part. So to get the left part, the right part is going to be the array that you have divided. Remember, now we have a midpoint, so you can just call in the midpoint. So the midpoint is going to be from mid to the rest of the list. Then the left part is going to be the array from the beginning part of the midpoint. That's it. We have our first logic. So there actually, now since I told you it divides the problem and then recursively solves it, you're going to sort these individual parts alone. So we shall sort the left part alone, then we shall also sort the right part alone. Now we need the logic for sorting these left parts and right parts. So we shall declare variables. We shall have a variable called I, we shall have a variable called J. These are going to be helping us in the sorting of the left part and the right part. Then we shall need a variable that will help us to determine the sorting bit, which is going to be a K variable. And actually we can just say I equals to J. Since they are all going to be equals to 0, we can just do this, a little bit of a trick, which is the same thing I was going to do earlier on. Then now we need to create, we first think through, we need to continue running if that length of the array is greater than 0. So we shall use a while loop. So while I, that element at that particular point, is less than the length of our left part, which we are trying to sort now, and at the same time J, which is now our right part of the list, is less than the length of the right part. So basically here saying if the list or the left part or the right part is greater than 0, the length, that means continue sorting. So here we now create the logic. So we say if the left part at I now is less than the right part of course, which is at J, remember that element, that means we shall now use our determinant, which is the K variable. That means the array is equal to the array at K, because that's what our determinant sorting variable is going to be, the left part, which is I. Yes, I hope this makes sense. Then since we're in the while loop, just have to increment the variables. So we just say I plus 1, then K, increment also K plus 1. Now what if the left part is greater than the right part. We need an else statement. So from here, you can just say else, and the right part now is more. That means our k will be equal to this. So we shall just say array at k, which is a searching variable, is going to be equal to right, which is j. So that means we increment j. We increment j with a +1, then we also increment a k again. We increment a k again with a +1. Actually, to avoid repetition, we can remove this from here. We just put this here. This takes care of this incrementing here and here. It's the same thing that we've done. So we move on. Now, what if we have elements that are still left, maybe in the left part of the list? So now we have to create another while loop here. We shall say while I is less than the length of left. That means our k equals to left. That is very easy. So we shall just say, shall call this again. Our k equals to left, which is array. Control V. Then that means we shall also increment our I. Then we shall also increment our k. So we do the same thing for right. While j this time round to the right part is less than the length of the right part at that particular moment. So that means we shall call this again also, and increment our k. Since we are working with a while loop, that's it. I believe the program is ready. So we test with a list, which is going to be 23. I don't know why I like 23. 43, 90, 902, 4, 67, 8, 12, 60, 69, 34. That's it. Let's do this. So we shall call our function under this array. Then we shall bring something up. So we save this. So let's run the program to test. See if we have any errors. We shall set by max sort. Run, you see, we get an error. Did you mean array? So we have an error here on line 3. It's good to learn how to debug. So come up here, so put in the array. First look through if it's near the same mistake we've made. Array, that's it. It should be working. So call it again. 4, 8, 12, 22, 43. Our list array is sorted. Thank you so much for your time, and I'm glad that you chose this particular video. Once again, please kindly subscribe, leave a comment for any other further discussion. Have a great one.